My Pico 2's finally arrived, so let's get some code onto the Pico 2. But before we do that, we need to update the toolchain. In this video, I'm going to explore those updates, particularly for the Mac, but I'll touch on the other platforms too, and then show the modifications needed to write a Blink firmware for the Pico 2. Let me show you how. Hi, I'm John, your concierge to the world of the Raspberry Pi Pico, Pico 2, robotics, IoT, and other fun tech. Remember to subscribe and join the community. Apart from telling the toolchain we're using the Pico 2 and RP2350 platform, our firmware application looks pretty much the same as what it did for a Pico. But before we can run it, we need to do some tedious updates to the toolchain. If you're a Mac user like me, you probably remember the pain and suffering of getting OpenOCD to compile. That certainly wasn't fun in SDK 151, and in 2.00 it's a problem too. But I think I've got the workaround and I can show you how to do it. If you like this video and it helps your learning or projects, why not drop me a cash tip using the super thanks button below the video. I'm saving these up to get myself to open source in San Francisco next year, and I'd appreciate your help in getting me there, and I hope to see you there too. Please hit that like button on the video and subscribe for more. So what I want to do here is really be able to flash C++ code onto our Pico 2. I could of course do that via bootstrap and go take the UF2 file onto the device just like a USB key, but actually that's really fiddly and it doesn't really work for my development strategy. So what I want to do is be able to use the SWD port, that's that port down the back of the Pico, and to flash the code on through there using OpenOCD. And that's what I'm going to show how I can actually do successfully in this video. I could not produce these videos without help from my sponsors. Today's video is sponsored by WolfSSL. I first came across WolfSSL when I was working on an IoT project and trying to secure MQTT. I needed a library to help add TLS to my communication. WolfSSL has a great library for just that, under either open source or commercial license, with support too. I've been using it on Pico and PicoW projects ever since. WolfSSL have other great products too, including a crypto library, a secure boot process to validate firmware, SSH clients, and TPM20, a trusted platform module library. Whether you're a hobbyist or building commercial embedded systems, WolfSSL's products are fabulous accelerators. Having them as a sponsor, I am sure I'm going to showcase some of their products over the coming months. So please do check out WolfSSL. To work with the Pico 2, we're going to need to update our toolchain. So the compiler should be okay, but we need to update some of the build tools, particularly OpenOCD and the SDK itself. Now, I'm going to just talk briefly through this and particularly about some of the things that you need to do for a Mac. But actually, I talk a lot about really the proper build chain for the Pico in my Udemy course, and you might want to check that out. Admittedly, that course has not been updated yet for the Pico 2, but I will put some additional Pico 2 content into that course at some point soon. If you're on Windows, then updating to the new version of the SDK should be really easy. It should just be a matter of issuing the Pico set up Windows Toolchain installer again and rerunning it. But unfortunately, that installer has not been updated to the Pico SDK version 2.0.0, and in fact Raspberry Pi are not going to do that or support it. Instead, they are suggesting that we all move over to running and doing all our compilations within Visual Studio Code. I'm not sure that I like that idea particularly, and certainly it's one that I haven't looked at for this video. If you did run in and install your Pico setup Windows in Toolchain installer last time and you want to do that again, the good news is you will be able to do that because Nikhil, who actually wrote that installer, is actually doing a local version of it, and it's going to be on his repo, and there's the URL for his repo there. So you'll be able to actually do an install via this. It's just coming out in the next few days, weeks, very soon, he tells me, honest. On Raspberry Pi OS, well, we had the Pico setup installer that's from Raspberry Pi themselves, and that's really easy to run and will update your toolchain too. If you're on Ubuntu or another Linux distribution, or you're on a Mac like me, then I'm afraid this is a bit more DIY, but that's okay. It's not that painful. Well, it is a bit painful, but it really is. It's quite achievable. So the Pico SDK itself, well, we need to actually pull down a new version of that and update it to the 2.0.0 release and update any of the submodules that are in there. And these scripts will actually get us through that command set. Of course, we also need the environmental variable pico SDK path to point to that. Now that on a Mac is generally set within the .zprofile configuration in your home directory. On Ubuntu, generally that's under .bashrc. Both of these depend on what shell you're using. If you've chosen to use a different shell than the default, then you might have to alter that. OpenOCD, well, this is what we're going to use to actually flash the Pico via that SWD port. And we again need to pull down a new version of that because there is again a 2.0.0 version of OpenOCD from Raspberry Pi to actually work with the Pico 2. Now, theoretically, the building of this should be relatively easy. It's just about bootstrapping, configuration, make and make install. But in actual fact, particularly on the Mac, this is actually quite painful. So on the right hand side there is a whole load of additional packages installed by Brew that we need in order to make OpenOCD compile work. And if you're on a Mac M2 rather than an M1 or an Intel, then you actually need a slightly different version of the compiler or it won't work either. So there's a little bit of work you need to do to make all of this work okay. Now, even with that done, I found that I couldn't build it, and I found that I was getting this error message here that there is a cast problem, and this is actually pretty poor code trying to cast a pointer to an 8-bit unsigned integer to a unsigned 32-bit integer pointer. That's really not particularly correct C and C++, so it's no wonder that this got thrown out. So I've produced a little bit of a fudged version of it, which I think gets around this problem, but I haven't confirmed that the RISC-V code still works, which is where this is coming from. And indeed, I'm not entirely sure I'm going to use the RISC-V code, so that may not be a problem, but it at least gets me to a point where I can have a buildable version of OpenOCD now, today, and use it to actually deploy. So in my Git hub repo, under the OpenOCD hack folder, you'll find a new version of batch.c, which you should be able to copy over into your OpenOCD source, and that should actually fix that build problem, and it at least will give you that binary. So let's have a look at my Blink example as the first bit of firmware that we're going to run on our Pico. And this, of course, is just going to blink the onboard LED on our Pico 2. So here in the repo, I've got a couple of examples here, my Blink example and another one actually calculating the value of pi. But let's just talk about the Blink one. Now, for an RP2350 or Pico 2 project, there are a couple of changes we need to do in the top level CMakeLists.txt file. We need to set the Pico board definition to be Pico 2, and we need to set the Pico platform to be RP2350. I sort of expected the Pico board being set to Pico 2 would automatically result in the Pico platform being set, but in my test that doesn't seem to actually happen, so do set both of those. Then actually the code, Well, actually, let's talk first of all. The source level CMake file is exactly the same as we'd normally do. The only caveat I'd say in here is you probably know if you followed my channel that I normally switch what I'm using for the UART pins to be on 16 and 17. Well, that still works and it works absolutely fine, but I sometimes switch them round and get that wrong of which one's actually TX and which one's RX. If you do now, the latest version of the SDK will moan at you. So you get forced to get them right, even though, to be honest, the code that gets generated makes no difference either way. And finally, what's in main and the main code? Well, this is just the same as any other Blink program, really, from a Pico. The Pico default LED pin is just the same as it was, and all of the other code is just the same as it was. So nothing else has changed there. So just a couple of little tweaks to get a compile for an RP2350. To flash the Pico via SWD, we actually need to use this OpenOCD command. It's quite verbose, and you'll notice that now we have a target line that's talking about the RP2350, where it used to talk about the RP2040. So that's, otherwise it's pretty much the same command that we've been using all the time. Now, of course, I can't remember this command any more than you can, I'm sure. So what I have is actually a script called pico-deploy.sh, which actually does all that for me. And it's quite clever. It can actually find my binaries for me, or I can actually give the binary in the ELF location on the end of it. Now, to help you out, if you would like a copy of this script, I've included it in the repo as well. It's yours, go enjoy. No warranty, but it works and I use it all the time and have been for some time. It makes some assumptions about your build environment and that you're running it within the build folder, and it will then try and find the binary from there. If it can't, it will moan about it. It will auto detect if you're targeting an RP2040 or an RP2350 by interrogating the binary. And you can also use an environmental variable pico-sdk to set back to some legacy options for flashing if you wanted to, but I wouldn't worry about that. But that's what I use to deploy, and I just hit the command pico deploy and off we go. So let's just demonstrate that script. So I'm here in my build directory, and I can just issue the command pico deploy, and all of the flashing happens, and the Pico 2 is off and running. And here's the Blink demo running, and you can see we've got text actually saying when it's blinking on and off, and you can see the LED blinking on and off there. So I have a Pico 2 build environment up and running, and I'll try out some of the more interesting new features for the Pico 2 in a future video. If you like this video and it helps your learning or projects, why not drop me a cash tip using the super thanks button below the video. Remember, I'm saving these up to get myself to open source in San Francisco next year, and I'd appreciate your help in getting me there. And I hope to see you there too. Thank you very much for watching. If you enjoyed the video, then please do hit that like button, and please subscribe to my channel so you don't miss the next video. Goodbye for now.